When Western intelligence satellites first spotted these machines, analysts couldn't believe their eyes. Aircraft so massive they needed 6 engines, tanks with 5 turrets, and flying boats that, honestly, just seemed to defy physics itself. Today on Sci and Why, we're unveiling 10 Soviet engineering marvels so outrageous that the world thought they were propaganda hoaxes. These weren't just machines, they were statements of impossible ambition, each one pushing the boundaries of what engineering could achieve. From sky giants to land battleships, these Soviet creations didn't just challenge expectations, they shattered them completely. The Antonov An-225 Mriya, the sky giant. The Antonov An-225 Mriya was so massive it could carry 50 cars in its cargo hold, and it needed 6 engines just to get off the ground. The An-225 Mriya, meaning dream in Ukrainian, was the largest aircraft ever built. Designed in the 1980s by the Antonov Design Bureau, this colossal cargo plane measured 275 feet long with a wingspan of 290 feet, longer than a football field. Originally created to transport the Soviet Buran space shuttle, the An-225 featured 6 Progress D-18T turbofan engines, producing over 300,000 pounds of combined thrust. Its cargo hold stretched 142 feet long, 21 feet wide, and 14 feet high, spacious enough to transport entire locomotives or wind turbine blades. The aircraft's 32-wheel landing gear system distributed its maximum takeoff weight of 640 tons across multiple contact points. Only one An-225 was ever completed, making its maiden flight on December 21, 1988. The aircraft set 110 world records simultaneously during a single flight in 1989, including heaviest aircraft ever built and largest wingspan of any operational aircraft. After the Soviet space program ended, the Mriya found new life hauling oversized cargo for commercial clients, becoming a global sensation wherever it landed. Tragically, this unique aircraft was destroyed during the 2022 Russian invasion of Ukraine at Antonov Airport, though plans exist to rebuild it using parts from the second incomplete airframe. The T-35 heavy tank, the land battleship. The T-35 was the only 5-turreted tank ever mass-produced, requiring a crew of 10 soldiers to operate its multiple weapon systems simultaneously. The Soviet T-35 heavy tank represented the ultimate expression of interwar multi-turret design philosophy. Measuring 31 feet long and weighing up to 55 tons, this land battleship featured 5 turrets armed with 176mm cannon, 2 45mm guns, and up to 7 machine guns. The main turret housed the primary 76.2mm KT-28 cannon with 360-degree rotation, while 4 smaller turrets provided overlapping fields of fire. Its massive size required a crew of 10 soldiers, including a commander, driver, radio operator, and multiple gunners. The T-35's complex design created internal cramping, with fighting compartments separated from each other and some turrets blocking entrance hatches. Powered by a 500-horsepower Mikulin M17M engine, the tank achieved a maximum speed of only 19 miles per hour due to its enormous weight. Between 1934 and 1939, only 59 production models were built at the Kharkov locomotive plant. The T-35 served primarily as a propaganda tool, participating in Red Square parades to demonstrate Soviet military might. During World War II, most T-35 tanks were lost due to mechanical failures rather than enemy action, proving that complexity doesn't always equal effectiveness. Despite its impressive appearance, the T-35 demonstrated the limitations of multi-turret tank design, leading to simpler, more reliable designs. The Lund-class Ekranoplan, the flying warship. The Lund-class Ekranoplan was the only ground-effect vehicle ever deployed as an operational warship, flying just 13 feet above the water at 342 miles per hour. The Lund-class Ekranoplan represented a revolutionary fusion of aircraft and naval vessel technologies. Designed by Rostislav Alexeyev in 1975, this massive ground-effect vehicle measured 242 feet long with a 144-foot wingspan, weighing over 380 tons. The Lund operated using ground effect, a phenomenon where air compressed between wings and water surface creates a high-pressure cushion for lift. This allowed the craft to fly at altitudes of just 13 feet above water, while achieving speeds up to 342 miles per hour. Armed with 6 P-270 Mosquet anti-ship missiles, The Loon served as a high-speed missile platform for the Soviet Caspian Flotilla from 1987 to the late 1990s. The International Maritime Organization classified ekranoplans as maritime ships, rather than aircraft, due to their unique operating characteristics. The Loon's military advantage lay in its ability to avoid underwater torpedoes like surface ships, while flying too low for radar detection like conventional aircraft. Only one Lun-class ekranoplan was completed before the Soviet Union's collapse ended the program. The surviving vehicle now sits preserved on the Caspian coast in Dagestan, Russia, serving as a monument to Soviet engineering ambition. Despite its innovative design, the Loon's operational limitations, including rough sea restrictions and saltwater corrosion, prevented widespread deployment. The Buran Space Shuttle, the Soviet space plane. The Buran Space Shuttle completed a fully automated orbital flight and landing in 1988, something NASA's space shuttle was never designed to do. The Buran spacecraft represented the Soviet Union's ambitious response to America's space shuttle program. Development began in 1974 with over 1,000 companies across the Soviet Union contributing to construction. Unlike NASA's shuttle, Buran launched aboard the expendable Energia rocket, with main engines remaining on the booster rather than the orbiter. The spacecraft measured similar to the American shuttle, but featured crucial differences in design and capability. Buran's most remarkable achievement was its fully automated flight capability. The spacecraft could launch, orbit, and land without human intervention. On November 15, 1988, Buran completed its only spaceflight, orbiting Earth twice in 208 minutes before executing a perfect automated landing. The mission demonstrated advanced Soviet computer technology and flight control systems decades ahead of their time. Buran was designed to carry up to 6 crew members and 30 tons of cargo to orbit, with the ability to return 20 tons to Earth. The spacecraft featured different thermal protection materials and could perform missions lasting up to 3 weeks. Despite its technological success, the Buran program was cancelled in 1993 due to the Soviet Union's collapse and funding shortages. The only space-flown Buran was destroyed in 2002 when its storage hangar collapsed at Baikonur Cosmodrome. The program's legacy lives on in modern Russian space technology and serves as proof of Soviet engineering excellence. The VDNKH robot, the Soviet android dream. Soviet engineers created humanoid robots in the 1950s that could perform 18 different commands, see, hear, and interact with amazed exhibition audiences. The VDNKH robot represented the Soviet Union's early venture into humanoid robotics and technological showmanship. Developed by young technicians under Boris Vasilenko's guidance, these robots were designed to demonstrate Soviet technological capabilities at the famous VDNKH exhibition center in Moscow. The most advanced model stood 1.8 meters tall and could execute 18 different commands via radio control, including movement, gesture recognition, and basic interaction. These robots featured primitive vision and hearing capabilities using sensors to detect light and sound for responsive behavior. The VDNKH robots performed every 2 hours on a special stage built in front of the Electrification Pavilion, drawing crowds of amazed visitors. Beyond their mechanical functions, these robots symbolized Soviet optimism about the future, representing a vision where automation would support human progress. The project combined engineering innovation with theatrical presentation, capturing public imagination about human-machine collaboration. Soviet robotics development extended beyond exhibitions. By 1980, the USSR operated over 6,000 industrial robots, representing more than 20% of the world's total. The country pioneered planetary rovers, developing the first lunar rovers and Mars exploration vehicles. While primitive by modern standards, the VDNKH robots played a significant role in robotics history, demonstrating early concepts of autonomous behavior and human-robot interaction that would influence future development. The MAZ-7907, the 24-wheeled nuclear transporter. The MAZ 7907 remains the only vehicle ever built with 24-driven wheels, designed to transport 100-ton nuclear missiles across any terrain. The MAZ 7907 represented the ultimate expression of Soviet heavy transport engineering. Developed by the Minsk automobile plant in 1985, this colossal vehicle was designed specifically to transport the RT-23 Molodets intercontinental ballistic missile. Measuring 92 feet long, 13.5 feet wide, and 14.4 feet high, the MAZ 7907 featured an unprecedented 24-wheel drive system with 12 axles. Two 1,250 horsepower, Klimov GTD 1,250 TFM gas turbine engines, borrowed from T-80 tanks, powered electric generators that drove individual 30-kilowatt motors at each wheel. This turbine electric transmission system provided exceptional traction and maneuverability across difficult terrain. The vehicle's articulated frame design allowed it to navigate rough roads while maintaining stability for its 150-ton payload capacity. 8 of the 12 axles were steerable, enabling the 92-foot vehicle to achieve a turning radius of just 88 feet. The MAZ 7907's independent hydropneumatic suspension provided 6.6 feet of ground clearance and exceptional off-road capability. Only 2 prototypes were ever built before the Cold War's end eliminated the need for road-mobile nuclear missiles. One MAZ 7907 was famously used in 1996 to transport an 88-ton ship 250 kilometers across Belarus, demonstrating its incredible hauling capacity. The surviving vehicle now resides in a museum representing the pinnacle of Soviet heavy transport technology and the lengths engineers would go to move the unmovable. The Caspian Sea Monster, the original Ekranoplan. The KM, also known as the Caspian Sea Monster, was so massive and mysterious that, honestly, American spy satellites just couldn't figure out if it was a plane, a ship, or maybe even some kind of secret weapon. The KM, or Korabl Maket Ekranoplan, which CIA analysts nicknamed the Caspian Sea Monster, was actually the world's first operational ground effect vehicle. Developed by the Central Hydrofoil Design Bureau back in the 1960s, this experimental craft measured an incredible 348 feet long, with a wingspan of 123 feet, making it the largest aircraft in the world from 1966 all the way to 1988. The KM used ground effect, flying within just 13 feet of the water's surface, where compressed air would create a sort of lifting cushion underneath. 8 massive turbofan engines gave it the thrust to reach speeds up to 300 miles per hour, skimming right across the Caspian Sea. Now, when American satellites first spotted the KM in 1966, intelligence analysts were, well, absolutely baffled by its purpose and appearance. The craft looked like nothing they had ever seen before, way too large to be a conventional aircraft and just too fast to be any kind of ship. The CIA's confusion actually led to some pretty elaborate surveillance attempts, including, believe it or not, plans to use robotic birds for closer reconnaissance. The KM began its operations in 1966, and underwent continuous testing by the Soviet Navy until 1980. This massive craft really demonstrated the viability of ground effect flight for military applications, and it ended up inspiring later Ekranoplan designs. Its career came to an end in 1980, when pilot error caused the KM to crash into the Caspian Sea, though thankfully, no lives were lost. The KM's legacy still lives on in modern ground effect vehicle development, proving that Soviet engineers were honestly decades ahead of their time in exploring these unconventional flight technologies. The Tsar tank, the tricycle fortress. The Tsar tank featured 2 massive 27-foot diameter wheels in front and looked more like a giant tricycle than a military vehicle. The Tsar tank represented one of the most bizarre armored vehicle designs in military history. Officially designated as the Netopir, or Bat, this enormous machine was built in 1915 during World War I as an experimental breakthrough weapon. The tank's most distinctive feature was its massive front wheels, each measuring 27 feet in diameter, with a smaller 5-foot wheel at the rear creating a tricycle configuration. This unusual design was intended to cross trenches and obstacles that would stop conventional vehicles. The Tsar tank measured over 60 feet long and stood nearly 30 feet tall, making it visible from great distances. 240 horsepower engines powered the front wheels, while the rear wheel provided steering control. The vehicle's crew compartment was positioned between the giant wheels, armed with multiple machine guns and cannons. Despite its imposing appearance, the Tsar tank proved to be a mechanical disaster during testing. The massive front wheels created enormous ground pressure, causing the vehicle to become stuck in soft terrain. The rear wheel was too small to provide adequate support, causing the tank to tip backward when climbing obstacles. After several failed tests, the project was abandoned in 1915, and the prototype was left to rust in the Russian countryside. The Tsar tank's failure demonstrated that bigger isn't always better in military engineering, though its audacious design continues to fascinate military historians and engineers today. The Mil V-12 Homer, the flying praying mantis. The Mil V-12 helicopter was so enormous it needed 6 crew members, including an electrician, just to keep it airborne, and it still holds the world helicopter lifting record. The Mil V-12, nicknamed Homer, represented the ultimate expression of Soviet helicopter engineering. Unveiled by the Mil Moscow helicopter plant in 1968, this colossal rotorcraft measured 67 meters from rotor tip to rotor tip, making it the largest helicopter ever built. The aircraft's distinctive appearance, resembling a praying mantis in permanent threat display, reflected its ominous purpose, transporting intercontinental nuclear missiles to launch sites. 4 massive turboshaft engines powered the V-12's twin rotor systems, requiring a crew of 6, including an electrician, to manage the complex electrical systems. In 1969, a brave test crew achieved an unbreakable world record by lifting a 40,000-kilogram payload to an altitude of 2.25 kilometers. The helicopter's side-by-side rotor configuration eliminated the need for a tail rotor while providing exceptional lifting capacity. Despite its impressive capabilities, the Mil V-12 became obsolete before entering service due to the development of mobile missile launchers. The strategic shift toward road-mobile nuclear missiles eliminated the need for helicopter transport, making the V-12 redundant. Only 2 prototypes were ever built before the program ended in 1974. One surviving aircraft is preserved at the Central Air Force Museum near Moscow, where visitors can witness this engineering marvel firsthand. The Mil V-12's legacy demonstrates Soviet willingness to push engineering boundaries regardless of practical limitations, creating machines that existed at the very edge of possibility. The screw-propelled vehicle, the all-terrain spiral. Soviet engineers created vehicles that moved using giant rotating screws instead of wheels, capable of traveling through snow, swamps, and even water. The Soviet screw-propelled vehicle represented one of the most unusual transportation solutions ever devised. These vehicles, known as Archimedes screw vehicles, used large helical screws instead of conventional wheels or tracks for propulsion. The rotating screws could grip virtually any surface: snow, mud, sand, or even water, providing unmatched all-terrain capability. Various models were developed throughout the Soviet era, from small personnel carriers to massive cargo transporters. The screw's helical design allowed the vehicles to literally swim through soft terrain that would trap wheeled or tracked vehicles. Some variants featured multiple screws arranged in parallel, providing redundancy and improved stability. The vehicles could traverse frozen rivers, deep snow, marshlands, and even open water with equal ease. Soviet engineers experimented with different screw configurations, including variable pitch screws that could adjust their grip based on terrain conditions. These vehicles found applications in Arctic exploration, military logistics, and remote area transportation, where conventional vehicles failed. The screw-propelled design proved particularly valuable in Siberian conditions, where extreme cold and varied terrain challenged traditional transportation methods. While never mass-produced, these vehicles demonstrated Soviet engineering creativity in solving unique transportation challenges. Modern versions of screw-propelled vehicles continue to be used in specialized applications, proving that sometimes the most unusual solutions are the most effective for extreme conditions. From flying battleships that skimmed the seas to tanks with 5 turrets and helicopters that could lift entire buildings, these Soviet machines pushed engineering to its absolute limits. Each creation represented bold thinking that refused to accept impossible as an answer. If you're amazed by these incredible engineering marvels and want to explore more mind-bending Soviet innovations, smash that like button, share your favorite machine in the comments, and subscribe to Sci and Y for more journeys into the world's most extraordinary technologies. Thanks for watching. Keep dreaming big. When NASA's deep space monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But you know, the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Sci and Y, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The lonely pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary, a deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 Alert Protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object, but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise, they contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers use to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed, almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long-unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. the spacecraft's golden record carrying sounds and images from Earth might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite. When CERN's Large Hadron Collider smashed protons together at unprecedented energies, scientists weren't just hunting for new particles. They were searching for something far more extraordinary: microscopic black holes. These quantum-scale phenomena, predicted by cutting-edge theories involving extra dimensions, could revolutionize our understanding of gravity and space-time itself. Today on Sci and Y, we're unveiling what really happened when the world's most powerful particle accelerator went hunting for the universe's most mysterious objects. The quest for quantum black holes. CERN's scientists embarked on one of the most ambitious experiments in physics history, deliberately trying to create black holes in a laboratory setting. The search for microscopic black holes at CERN represents a fascinating intersection of theoretical physics and experimental reality. Unlike the massive black holes found in space, these quantum black holes would be incredibly tiny, existing at subatomic scales and lasting for mere fractions of a second. The CMS experiment at CERN's Large Hadron Collider has been actively searching for these phenomena since the facility's early operations. According to CERN's official documentation, some theoretical models suggest that microscopic black holes could form when particles collide with sufficient energy, particularly if our universe contains extra spatial dimensions beyond the familiar three. These theories, including the Arkani-Hamed-Dimopoulos-Dvali model and the Randall-Sundrum scenario, propose that gravity might be much stronger at quantum scales than previously thought. The LHC's proton-proton collisions at energies up to 13 TeV create conditions where, according to these models, space-time itself could briefly collapse into microscopic black holes. If formed, these quantum objects would immediately evaporate through Hawking radiation, producing distinctive particle signatures that CERN's sophisticated detectors could potentially observe. The theoretical foundation. The possibility of creating black holes in particle accelerators stems from revolutionary theories that suggest our universe has hidden dimensions we can't perceive. The theoretical framework for microscopic black hole production relies on models involving extraspatial dimensions. In standard four-dimensional physics, creating a black hole would require concentrating energy equivalent to about 10 to the 19th GeV, far beyond any human-made technology. However, theories like the ADD model propose that gravity might propagate through additional dimensions, while other forces remain confined to our familiar three-dimensional space. This would effectively lower the energy threshold for black hole formation to potentially just a few TeV, precisely within the LHC's operational range. Dr. Lisa Randall and Raman Sundrum developed influential models suggesting that if extra dimensions exist, the fundamental scale of gravity could be much lower than previously thought. These theories emerged to solve the hierarchy problem, explaining why gravity appears so much weaker than other fundamental forces. If correct, when protons collide at nearly light speed in the LHC, they could concentrate enough energy within a tiny region to exceed the Schwarzschild radius, causing spacetime to collapse into a microscopic black hole. The mathematics behind these theories is elegant but complex, requiring sophisticated computational models to predict observable signatures. CERN's experimental search. Armed with the world's most sensitive particle detectors, CERN scientists began their systematic hunt for evidence of microscopic black hole creation. The CMS experiment at CERN has conducted extensive searches for microscopic black hole signatures in high-energy proton-proton collisions. Using data collected during the LHC's operations at 7 TeV center of mass energy, researchers analyzed collision events looking for the distinctive particle sprays that would result from black hole evaporation. According to CERN's published results, if microscopic black holes were produced, they would evaporate almost instantaneously through Hawking radiation, creating characteristic patterns of subatomic particles detectable by the CMS detector surrounding the collision point. The search methodology involved examining invariant mass spectra of particle jets, looking for anomalies that couldn't be explained by standard particle physics. Scientists used sophisticated Monte Carlo simulations to model expected black hole signatures, comparing these predictions against actual collision data. The ATLAS experiment has also conducted similar searches, analyzing electron plus jet and muon plus jet invariant mass spectra with 140 inverse femtobarns of collected data. These experiments represent some of the most sensitive searches ever conducted for quantum gravitational effects, pushing the boundaries of what's experimentally accessible in fundamental physics. The surprising results. After analyzing millions of particle collisions, CERN's results challenged expectations and honestly, revealed something unexpected about the nature of reality. The experimental searches conducted by both the CMS and ATLAS experiments have yielded some pretty fascinating results. No direct evidence for microscopic black hole production has been found in the energy ranges examined so far. The CMS experiment's analysis of 7 tera-electron-volt collisions ruled out the existence of microscopic black holes, up to masses of 3.5 to 4.5 tera-electron-volts, for various theoretical models. More recently, the ATLAS experiment search using 13 tera-electron-volt collision data set even more stringent limits, excluding quantum black hole production up to 9.2 tera-electron-volts in the Arcani-Hamed-Dimopoulos-Dvali model, and 6.8 tera-electron-volts in the Randall-Sundrum model. These non-observations are actually scientifically significant because they constrain the parameters of extra-dimensional theories. The absence of black hole signatures at these energy scales suggests that either extra dimensions don't exist as these models predict, or the fundamental scale of gravity is higher than theorized. However, these results don't definitively rule out microscopic black holes. They simply push the energy threshold higher, potentially requiring future collider experiments with even greater energies to test these theories conclusively. Safety considerations and public concerns. The prospect of creating black holes on Earth sparked widespread public concern, forcing scientists to address some pretty fundamental questions about experimental safety. Public fears about CERN creating dangerous black holes have persisted since the LHC's inception, and honestly, they've been amplified by popular culture and social media speculation. CERN has consistently addressed these concerns through comprehensive safety assessments and public education. According to CERN's official safety documentation, any microscopic black holes produced would be perfectly safe because they would evaporate almost instantaneously through Hawking radiation. The fundamental safety argument relies on cosmic ray interactions. High-energy particles from space constantly bombard Earth's atmosphere with energies far exceeding the LHC's capabilities, up to 10 to the 20th electron volts. If dangerous black holes could be produced at LHC energies, cosmic rays would have already created them throughout Earth's 4.5 billion-year history. Dr. John Ellis and other CERN physicists have emphasized that even hypothetically stable microscopic black holes would be harmless because they would interact so weakly with ordinary matter that they would pass through Earth without effect. The LHC Safety Assessment Group concluded that the experiments pose no conceivable danger, with multiple independent reviews confirming these findings. Hawking radiation and quantum effects. Stephen Hawking's groundbreaking theory predicts that microscopic black holes wouldn't grow and consume matter. Instead, they would explode in bursts of quantum radiation. Hawking radiation theory, developed by Stephen Hawking in the 1970s, fundamentally changed our understanding of black hole behavior. According to this theory, black holes aren't completely black but emit radiation through quantum effects at their event horizons. For microscopic black holes, this process would be extraordinarily rapid. Objects with masses comparable to elementary particles would evaporate in approximately 10 to the minus 27 seconds. The smaller the black hole, the more intense its Hawking radiation and the faster it evaporates. This creates a natural safety mechanism. Any microscopic black holes produced at CERN would immediately decay into standard model particles before they could interact with surrounding matter. The evaporation process would produce a distinctive spray of particles including photons, electrons, muons and quarks, creating detectable signatures in CERN's instruments. Theoretical calculations suggest that the temperature of Hawking radiation from a microscopic black hole would be incredibly high, potentially reaching 10 to the 17th Kelvin. This extreme temperature would cause the black hole to radiate away its entire mass almost instantaneously, making it impossible for such objects to grow or pose any danger to their surroundings. Implications for extra dimensions. The search for microscopic black holes at CERN represents honestly humanity's first experimental probe into the possibility that our universe contains hidden spatial dimensions. The theoretical models predicting microscopic black hole production are, intimately connected to theories of extra dimensions. These models suggest that our familiar three-dimensional space might actually be embedded in a higher dimensional reality, with gravity able to propagate through these additional dimensions, while other forces remain confined to our observable space. The ADD model, which was developed by Nima Arkani Hamed, Savas Dimopoulos, and Gia Dvali, proposes that gravity appears weak because it spreads out through large extra dimensions. Meanwhile, the Randall-Sundrum model suggests that we live on a three-dimensional brain within a five-dimensional space, with gravity concentrated near our brain by the geometry of space-time itself. CERN's experimental limits on black hole production provide, crucial constraints on these theories. The absence of black hole signatures at current energy scales suggests that if extra dimensions exist, they must be smaller or configured differently than some models predict. These results represent the first experimental tests of quantum gravity theories, providing invaluable data for theoretical physicists working to understand the fundamental structure of spacetime and the unification of quantum mechanics with general relativity. Advanced detection methods. CERN's scientists, have developed some truly revolutionary detection techniques to identify the fleeting signatures of microscopic black holes among millions of particle collisions. The search for these tiny black holes required developing really sophisticated analysis techniques to distinguish potential black hole signatures from ordinary particle physics processes. The CMS and ATLAS detectors use these multi-layered systems, silicon trackers, electromagnetic calorimeters, and muon chambers, to reconstruct particle trajectories and energies with, honestly, extraordinary precision. Scientists have also developed specialized algorithms to identify the high multiplicity particle jets that would result from black hole evaporation, looking for events with unusually large numbers of particles produced in spherically symmetric patterns. On top of that, machine learning techniques have been employed to analyze vast data sets, training neural networks to recognize potential black hole signatures among the billions of collision events recorded. The analysis focuses on invariant mass distributions, searching for resonances or anomalies that just can't be explained by standard model processes. Researchers use Monte Carlo simulations, which incorporate various black hole models, to predict expected signatures, then compare these predictions against real data using statistical methods. The detection challenge is immense. Potential black hole events would be extremely rare, requiring analysis of petabytes of collision data to identify possible candidates among overwhelming backgrounds of ordinary particle interactions. Future prospects and higher energies. As CERN prepares for even more powerful experiments, the search for microscopic black holes is, entering a new phase with unprecedented energy scales. The high-luminosity LHC upgrade, which is scheduled for completion in the late 2020s, will actually increase collision rates by a factor of 10, providing vastly more data for rare event searches. This enhanced capability could push the search for microscopic black holes to higher mass scales, potentially reaching the thresholds predicted by some extra-dimensional models. Looking ahead, future collider projects, including the proposed future circular collider, with energies up to 100 TeV, would provide even more sensitive probes of quantum gravity effects. The increased energy and luminosity would allow scientists to explore black hole production at mass scales up to 50 TeV or higher, definitively testing many theoretical predictions. Advanced detector technologies under development like improved calorimetry and faster data acquisition systems will enhance the sensitivity to black hole signatures. Theoretical work is also continuing to refine predictions, with new models suggesting alternative signatures that might be more easily detectable. Really, the combination of higher energies, improved detectors, and more sophisticated analysis techniques may finally provide the experimental breakthrough needed to either discover microscopic black holes or definitively rule out their production at collider energies. The broader impact on physics. Whether CERN finds microscopic black holes or not, The search itself is, honestly, revolutionizing our understanding of fundamental physics and the nature of reality. The quest for microscopic black holes at CERN represents more than just hunting for exotic objects. It's really testing the very foundations of our understanding of space-time, gravity, and quantum mechanics. The experimental limits already established have constrained theories of extra dimensions and quantum gravity, forcing theorists to refine their models and develop new approaches to unifying fundamental forces. The sophisticated detection methods developed for black hole searches have advanced experimental techniques across particle physics, improving our ability to discover other new phenomena. The safety analyses conducted for these experiments have also deepened our understanding of cosmic ray interactions and astrophysical processes. Even negative results provide valuable scientific information, ruling out certain theoretical possibilities and guiding future research directions. The interdisciplinary nature of this research has fostered collaboration between particle physicists, cosmologists, and theoretical physicists, leading to new insights about the universe's structure. As CERN continues pushing the boundaries of experimental physics, the search for microscopic black holes remains a powerful probe of reality's deepest mysteries, potentially revealing whether our universe truly contains hidden dimensions and whether quantum mechanics and gravity can be unified into a single theoretical framework. CERN's search for microscopic black holes represents humanity's boldest attempt to probe the fundamental nature of reality itself. While no black holes have been detected yet, the journey has revolutionized our understanding of physics and pushed the boundaries of what's experimentally possible. If you're fascinated by these cutting-edge discoveries and want to explore more mind-bending physics mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more journeys into the universe's deepest secrets. Thanks for watching. Keep questioning reality.